Okay, everybody, welcome to the second session of carrier measurements and calculations. Again, my name is Jason Riley. I will be your instructor for the three sessions, the 3 30-minute sessions. First of all, we're going to do some housekeeping. Number one is emergency escape, down the hall, out to the car park, and you'll be told where to go from there. You want to go to the toilet, out the door, hang a left, first corridor on the right, there are toilets down there. We also have an attendance sheet here. Can you guys please fill out the attendance sheet as we go along? Now, has anybody got any allergies? No? No? Nobody's allergic to measuring tapes or rulers or calculators? Anything like that?
I'm allergic to cats.
Oh, allergic to cats. Well, we'll see if we can keep the cats out of the room then.
Okay, thanks.
Okay, so you guys all received an email prior to this session. Now, in the email, there were some, which I've printed out and put on the desks for you, and it's the formula for each of the things we're going to be measuring up today. So we're going to be doing perimeter and area of a square rectangle. We're going to be doing perimeter area of a circle, and we're also going to be doing the volume of a cube and the volume of a cylinder. Okay, so as we go through this session, we're going to recap on some of the stuff we did on the first session. And then as we get to each individual one, I've got practice sheets also, which I've put out your desk for you on each one of those things. We've also got, we're going to be covering in this session to conversions of units. So we covered that slightly in the first session. It's going to be millimeters to centimeters, centimeters to meters, meters to millimeters, millimeters to centimeters, meters, everything. And we've got a practice sheet that we're going to be going over that too. Okay. So with that session, with that today, we will be, you'll be asked to write a little bit. So if anybody has got any issues with writing or anything like that, if you need any help while we're doing the calculation. So mainly this session, but is going to be about, we've got the measurements on the sheets. It's pretty much going to be using the calculator to work out what the actual final measurement is going to be. So today's going to be using the calculator and working out how to use the formulas for each one of these things. All right. Now, has anybody got any questions on that? Now, also too, what I've covered off earlier on, the first session. Everybody's all happy with that? As you can see, it flows into this one. The last session was why we use measurements, how we take them. We slightly touched on how we get the tool equipment we're going to use. Slightly touched on the conversion of the measurements, and now we're going to actually put those in practice. We're going to be using the formulas, and we're going to be working them out. Okay. Yeah. So you don't have to do it now. We're going to be going through it later.
Oh, okay.
Yeah. That's something I'm pretty sure. Yeah. Look, you've got. I know you're pretty good at this, but we'll go through it as a group together. So as we go through each area, we'll talk through each calculation. Okay. Everybody happy with the way the session's going to go today?
Yeah.
All right. No questions or anything? Everybody's fine using the calculator? Okay. And as I said, the formulas are on the sheets. Not only are they on the sheets, the handouts that were sent to you, they're on the practice sheet that we're going to be doing today. So all you've got to do is work out what's going on with the calculator. Okay, so the learning objectives are calculate perimeters, calculate the area of a rectangle, square, and compound shapes, calculate volume of a prism, and calculate that. As we touched on, here's the millimeters. 1 millimeter, 1,000 of them make a meter. 1 millimeter, 10 of them make a centimeter. 1 meter is 1,000 millimeters. Okay, so we're going to be going over the conversions later on in the class, and we've got practice sheets for that. Touch on this last section, perimeter and area. Perimeter. Perimeter is a boundary outside edge of the building. Industry is used to refer to things like fencing, gutters, external walls, and links. So it's the outside of an area. Area is the amount of space inside a boundary. Square units are used for area measurements such as meters squared, which we touched on earlier on. Examples include floor area of a building, wall, ceiling of a roof area, floor area of individual rooms, area of a building block, and here it is here. The area is the grass section. The perimeter is the outside. Okay. Now, perimeter of a rectangle. So now we're going to get into using the formula. Now they've got here a perimeter of a rectangle equals 2 length times width. So you could add up that and multiply it by 2 if you wanted to, or you could also do it, you could just measure that, and just add them all up. Okay? So it's length plus width plus length plus width. Okay? So we've got our practice sheets, we've got our formula sheets here, these ones here. Okay? And we've got our practice sheets here. So the first practice sheet we've got is perimeter of a square rectangle. Now, what are the measurements we've got in there?
20 millimeters and 50.
Right, I'll put this, I'll let Tommy.
That's all right.
Just got to go in that cabinet door, so you filming, mate, that's all. Thanks.
Okay, so we've got 20 millimeters plus 15 plus 20 plus 15. So we get our calculators out. 20 plus 15. So type in the calculations you got there.
We write the answer in.
Yep, you can write the answer in. And what do you got for that?
70 millimeters.
70 mils. Has everybody got the same?
Yeah.
All right. Now we've got the second one down there. What are the measurements for that?
24 and 27.
Okay. And how much is that?
2.
222 centimeters?
Yeah.
And as we can see, we're adding them up. And we don't put an M2 or millimeter 2 or M3 or millimeter 3 because it's just adding up the outside. Okay. So now with the third section of our practice sheet, well, what have we got?
We've got meters and stones.
And how much are they?
7 and 6.
All right. So 7 plus 6 plus 7 plus 6.
26.
Everybody same answers for that? What do we get?
26.
Now, what about the first one?
70. 70 millimeters.
Second one?
222.
And third one? 222. Pretty
What
good.
if we had this question?
Yep.
Explain further. If we had one type of measurement for one side and a shorter type of measurement for the other side, for example, 7 meters versus 6 centimeters, wouldn't we have to
Yep.
How would we do that?
If you convert it.
Right.
And we'll do conversions later on in this section. All right. So next we've got is area. And we've got some practice sheets on area and we've also got the formulas there. So if we flick over the page for the area, and we've got some math equations we've got to do for that. So you flick over to the next page on your practice sheet. All right. So what are the area we've got?
50 by 40.
50 by 40. And because it is an area, as we see in the formula, rectangle equals length times width, and we've already got the measurements here for you, where A equals number of square units in the area, L equals width, L equals length. All right, so what we've got here is because it's 2 measurements, we finish it off with a little 2 at the end of it to do an area. So we've got 50 times 40 equals 50 times 40, 2,000.
Oh, times.
Yeah, 50 times 40. Because we're doing area. We've got to multiply it.
So that would be
2,000
2,000 millimeters
squared.
squared.
With a little 2 at the end of it. All right.
So more already, aren't we? Let's put that in the messages. Oh,
That's okay. That's okay. We can catch up. We can catch up. So what's the second? Jess, what are the measurements in the second one?
25 by 12, so it's 30 centimeters squared.
25 times 12.
300.
Yeah. So if you multiply 25 by 12 in your calculator, we get 300 centimeters squared. Yep.
Wow.
In my eyes, you do. Okay.
300 centimeters squared.
Yep.
How long?
Okay. So what's the last one? What's the last measurements we've got here on this?
8.3 times 5.
Or whatever, go. We've got a decimal.
That's 20 millimeters.
41.5. Do we have to like convert it or
No, just like a meter squared. That's okay because not everything we measured out to the full number.
So we just do 8.5 by 5.
No, 8.3 times 5.
8.3 by 5, sorry. 8.3 times 8.3 times 5.
Equals,
41.5.
there we go. So there we go. That's your area of a square rectangle done as well. So we've got 3 exercises you've done and how to use your calculator. And you work out the measurements there and you put your little 2 at the end of it, that means square. Okay.
So
So, yeah.
sorry, that means that's the inside space.
Correct. That was the outside of it was a fence. That's the grass on the inside of the concrete. Yeah. So, next one we've got. Yep. So we're going to be talking about the perimeter of a circle is called its circumference. The distance from the center of a circle to any point of the circumference is called the radius. So that's halfway. All right. Okay. And the distance across a circle through the center is called the diameter. So that's all the way across. All right. So if we have something that's a circle in shape, which I've got over here for you, which is this. Well, yeah, here we go. I was standing in front of it. So your radius is halfway, diameter is all the way across, and what we're going to be looking at circumference all the way around. Okay? Now to do that, we have a formula. So whenever a circle is drawn, no matter the size, it's always the case that the circumference is approximately 3.1416 times the diameter. We refer to this figure as pi, the Greek letter pi. Okay? So that's pi. So the formula for circumference equals pi times diameter. So we've got a diameter here. I've already put the pi in the sheet for you. And so we've got to work it out, 3.1416. Times 30 perimeter. So it's not a 2 at the end of it because it's just a perimeter. So what measurement we've got? We've got 90.
94.248.
Yep,
Million.
correct. Yep.
Diameter, if it's circumference.
Yep.
How
That's
many
how much.
decimal places do you want us to?
That's all right. 3 will do. Whatever comes up because we've got pi going to 4. So, all right. So now we've got the next practice perimeter of a circle. What's that one? So 3.1416 times 50. 55, sorry, yep. It's 172.788.
So why have we restricted pi to 4 decimal places? Because what it's actually like 27.
Pi can actually go through infinite
Oh, cool. So why have we restricted it to just the 4?
because that's close enough to what we want to cut off, or how much area we need. You'll get it close enough to what we need. You might have to cut up a circle, a rug, or something like that. Patch, and that's all you need. That'll be
So
close
is that
enough.
standard unit of measurement for
1.1416, that's enough for us. And the last one, what have we got there?
4 meters?
Okay. So if we read those 3 out, what's the answer for the first one?
4.248.
And what have we got for the second one?
72.78.
172, was it?
Yeah.
Yep. And what have we got for the last one? 15, or was it 12.5664?
Yeah.
Everybody get the same?
Yeah.
Oh, good. So that's how we work out the perimeter of a circle. Okay. Now the next sheet we go over is the area of the circle. Okay. So instead of doing the outside, we are now doing the inside. Okay. We have the formula sheet there, which you can take home as well. You got the formulas on here, which will help you as well. Okay. So the formula for the area of a circle is pi r squared. So remember the radius is halfway across. and we're going to multiply the radius by itself, and then we're going to multiply it by pi. Okay, so it's 3.1416 times r, or pi over 4 diameter squared. Well, don't worry about the bottom one. We'll just use the top one. Okay, so we've got our calculator again. What's the first question we've got there? Pi times, and what's the radius of the circle?
20.
So we multiply 20 by 20 and by pi.
Does it matter which order we
Do
do
it
it?
any order you want, as long as you've got the 3 calculations there.
Would it just be easier with the scientific calculator so you can just
Some people can use the scientific calculator, but that takes another lot of training. So I just thought we'll use a basic calculator and do a lot of this. Right, so what do we get for the first one?
1,256.64 centimeters.
Beautiful. And because it's area, it's got a 2 next to the m in the centimetre.
Centimeters squared.
Yes,
Why is that? Why is that?
because we're multiplying and we're using 2 different calculations to multiply, so it's squared.
Didn't we multiply when we were doing the tournament?
That was all addition.
Can we do this?
Oh, for a circle, yeah,
Fine there.
but when it's the area inside, we use the centimetre squared because we're doing the square area of a shape.
Okay,
Even though it's a circle, it's a square area.
square area. So every time we do area, we have to have
2 at the end.
the 2 at the
Yep.
Okay. Every time we do area. Right.
All right, so now the second one, what's our measurements we've got for that? We've got pi, which is 3.1416 times 70 times 70. And what do we get for that?
15,394.8.
All right. Everybody get the same?
Yep, I think 15393.84 kilometers squared. Is that right?
You got that one?
Yeah.
All right, everybody following or everybody need a hand or anything like that? So far, so good. Well, that's what I like to hear. Okay, so now we've got the last practice question. So what have we got for that one? What are the measurements? We've got pi, which is 3.1416. So now this one's in metres. So if we do 2.5 by 2.5 by 3.1416, so we do 3.1416 times 2.5 times 2.5. Doesn't matter. No, doesn't matter at all. No, you can do them in any order you want.
They're really good at this. Okay. Yeah, 19.635. Is that what you got?
That's what I got.
Okay. I feel like I used to do all of them. Okay. I feel like, yeah, I can see.
Okay, so we'll go through those 3 measurements, and don't forget they end up with the 2 at the end of it. So what was number 1? It was 1256.64 centimetres squared.
Yeah.
Okay, what was number 2?
I think it was 15,393.84 square meters too.
Square.
Millimeters, I meant.
Millimetres, yeah. Okay, and so then we've got the area of the circle for question number 3. Now with that one, it was 2.5 metres, the radius, and pi 3.1614. What do we get for that?
19.635 meters squared.
Okay. So we did the area of a square rectangle. Can anybody come up with a suggestion of where we might use that? Sorry, the perimeter of the square rectangle. Where will we in your workforce? Fencing? Beautiful. I'll start.
Setting out for the front.
Yep. And what about the area of a square rectangle? Can anybody give an example of that where you guys can do?
Or the concrete. And the driveway.
Yep.
And when would we be using this area of a circle though?
Well, that's a good one. We'll use it for pizza.
Now we're doing the ponds. Ponds. Nice.
when we do put the ponds in. Is that correct?
It is correct, you use it for that, but what else? Is every lawn shaped square or can it be circle?
They can be any shape.
Well, I guess what about when it's on a hill though?
Well, then when it's on a hill, if it's going straight like that, it's still the same measurement.
Okay.
But then if it goes like that, then we have to break it down. But that'll be further on in the sessions.
Alright.
Okay. So we've got the area of the square rectangle and we've got the area of the circle, and we've worked out that we could use that for lawn. We're going to put in a pond. We've got the perimeter of the fence on a square rectangle area. That can be used for there. What can we? Yeah, cool fence.
Dragonfish.
Catfish.
Catfish. Yeah. So we're going to put in a pond.
Yeah, the catfish one. It's the Japanese.
Japanese ones.
They're quite cool.
Oh, no, catfish.
No, they're quite
Oh, really?
Yeah.
I swear to the same
And-
thing.
Just on that,
No?
if you're going to build a round pond with your catfish in it, you might need to know the diameter to build a bridge across it so you can look over and look at it. This is where all this comes into play. All right. And so we've got the area of a square, rectangle, area of a circle, perimeter of a square, circle, and as you can see, they can all be used for the same things.
Fish are poisonous.
Yeah, they can be. Don't eat them. You seen the episode of The Simpsons we had?
Dragonfish. No, dragonfish. They're pufferfish.
Pufferfish. That's the episode of The Simpsons where Homer nearly died.
I
Okay.
think it was the Simpsons episode, that looked like a dragon. That was alien.
Yeah,
That had too many eyes.
and Homer thought he was going to die, but he didn't die, so he's fine.
Yeah.
Has anybody got any questions on the formulas there? We've ran through some examples on how to use it. So I hope that goes all right with you guys now. You can take those handouts home, take those practice sheets home. I'm also going to send you an email prior to the next session with a whole heap of practice questions for you on each one. There's a lot. There's probably about 15 on each one.
Okay.
So you're right to go for the next session.
Does it come with an answer? Right?
Now, I'll check it for you.
Oh.
Yeah, you can bring them in the next session in a couple of weeks'
Do
time.
we have an exam, like with all this coming up? Like, is there an exam?
Not at this point in time. There will be one down in the future. We're doing the 3 sessions first, and then the exams coming after more sessions. We haven't put that in there yet.
How do we prepare for that exam?
How do you prepare? I'll send you an email with all the details on that.
All right, when will we get that?
After the next session.
But like, roughly when can we get that out? Because like I've got like training on and
I can get it as soon as possible. After this session, I'll send you that email. Okay. All right. So now we're going to be looking at volume. The volume of an object is the amount of space it takes up in 3 dimensions. All right? 3 dimensions. To measure volume, we use 3-dimensional units or cubic units such as millimeters cubed and m3. So remember how we had for the area, we had the 2 at the end? We've now got the 3 at the end. Okay?
why have we got 3 at the end?
Because it's cubed. It's because we're going to be taking 3 because it's a 3-dimensional shape. We're going to put the 3 at the end of it.
Okay. Why don't we call it a prism?
I'm not quite sure why they call it a prism. I would have just called it a cube.
Yeah.
But that's the wording they like. Probably just means the same.
It's anything with that.
Yeah. I don't think they keep prisoners in it. That's a different thing.
Probably the cell blocks are probably called.
Yeah. So calculations of volume of the construction, you do discern things like the amount of soil to be excavated, tile adhesive required, sand to use in bricklayers mortar or a tile is screed, tins and or buckets of paint, tubes of fixative required for a job, concrete required to pour a slab. Okay, so now we've got our prism. So you go over the sheet. Next sheet, you've got your formula, and you've got your practice sheet for a prism as well. The next sheet as well. Okay, so now we're going to be measuring this the length times the width times the height. Okay, so we're going to be doing 3 dimensions. Up here, across here, and up here.
And this is all multiplied.
Yes.
Wow. Thanks for telling me.
So yeah, it's on your formula sheet here. So the first one is 120 times 40 times 25.
120,000. Alright, is that correct? Yeah.
Yeah, and that's in millimeters, and it's going to have a little 3 at the end of the millimeters.
Yeah.
So what have we got for the next one?
19,000.
That's, yep, we've got 55 by 18 by 20, which is 19,800 centimeters cubed, which is a little
I
three.
lost it again.
Your plus, that's all right. That's all right.
No, I think it's the right page. No, I know, just finding the
This one's got the formula on it too. So
Oh, yeah. Yes. Oh, thanks.
they didn't get stuck yet. And the last one we've got is 9 meters times 3 meters times 6.
5 years.
So what do you got for the second one?
Oh, 19,800.
Centimeters
What's the unit?
cubed.
Yeah, but the cube one.
Yeah.
So cube as in what, 3?
3. Yep.
Oh, okay.
And the last one. So we're going to multiply
9 by 3 by 6.
9 by 3 by 6.
152.
Which should be 162.
Teacher, 13.
All right. Now,
Thank
this one's a little bit trickier because we're going to go back to our formula for our radius and diameter and height and all that, blah, blah, blah. So a cylinder, which is like this, okay? Our formula, which is a volume of cylinder, which is a cylinder is a solid shape with 2 identical ends that are the same size and same shaped circle and parallel to each other. So it's measured in metric meters, in M3, whatever the measurement is, millimeters, centimeters, meters. The formula is pi r squared times height. All right, so we've got our practice sheet there, so we need to click over to the sheet for that, and we need to start putting those in. Run a little bit late, but we'll get there. So it's 3.14.16 times 40. It's radius squared, so we've got 40, so 40 twice, and the height is 50 in the first one. What'd you get for that?
25. 3, 2, 8, 9.
Yep, you want to hand? So
Yep.
3.1416 times 40 times 40. 40, yep,
Yep.
times 50 for the height
Mm-hmm.
equals.
All right.
Yep.
Is it pi square? What is it?
It's cubed with all 3 again.
3.
All right, so we've got 3.146 for the next one. Here's a get your pi times 15, so 16. 15 times 15 times 12 for the height equals 8482.32. Going to go over a little bit. That's okay. I'll only be half a minute. All right, the last one we've got 3.1416 times 2 times 2 times the height, which is 5. We've got 62.832 meters cubed. Did everybody get those 3?
Yep, yep.
Okay, now has anybody got any questions on anything that we've used today? Okay, so if we've got, if we use an area, what number do we put at the end of our measurement?
Square.
Yep, 2. And if we've got cube, what number do we put at the end of that?
3. That's volume.
Yep, it's 3-dimensional objects. All right, so on that, that's our session for today. Oh, I bet we went over.
Tracking them.
So, okay, so we're going to convert meters and millimeters. and we've got our practice sheet for that. So the practice sheet has got the formula in that. Okay, so as we touched on earlier on, and we've got the formulas here, we've got 1,000 millimeters makes a meter, got 10 millimeters makes a centimeter. So we've got the first one there, meters, converting the following meters, 3.2 meters to millimeters. So we've got to multiply the 3.2 by 1,000.
20,000.
Yep, equals 3,200. Beautiful. That's what that is in millimeters. Okay. Now what we've got next, we've got 1.5 meters. So we've got to multiply the 1.5 by 1,000.
1.6.
Or 1.6 is so my eyes not
Why
there.
down?
Yeah.
Is that
So that's 1,600 millimeters.
And so, because we already know what to do for those ones, can we maybe stick to centimeters just for
It's okay. Yep. So which one do you want to go to? The bottom one?
yeah, if you guys know how to do meters, can we stick to centimeters?
No, I don't, I'm not too sure.
Okay.
So if we want to go from meters to centimeters, we
Okay.
then have to times it by 100, right?
Correct. All right. So convert.
6 foot 1 times 100, right?
Yep.
Gives us 6 foot.
So that's how many centimeters are in a meter is. So that's 600.
Oh, yeah.
6.1.
6.1 times
100
100.
because we've got 100 centimeters in a meter.
Yeah.
We've got 1,000 millimeters in a
Where's
meter.
the centimeter? Yeah.
So 1.8 would be 180.
Correct.
I did that one without the calculator.
I mean, there you're learning.
With a 0 at the end of it. 13. Cool.
Okay.
And we get to take these home with us?
Yep.
Excellent. Have we had any further questions?
You can always contact me. I'll be sending out the email. All right. So prior to the next session, I'm going to be sending out an email with a lot more practice sheets. Okay. There'll be a lot more for every sheet, every formula used here, because the next session, what we're going to be doing is we're going to be actually measuring stuff in the workshop. All right. So does anybody have any questions on today's session? Okay.
That was good.
I will be supplying everything too. You don't have to really bring anything with you. I'll have all the measuring equipment here. So, no, that's all good. Everybody happy?
Yeah, excellent. Thanks so much.
Thank you.
Bye, Jen.
See ya.